Welcome to video 6 of section 2 of our solutions 1 unit. Today we're going to talk about solution stoichiometry. So we're going to add molarity in as a conversion factor for solving stoichiometry problems. So in the past we've done things like mass to mass problems using a balanced chemical equation. We are going to be adding a volume to this now. So in this case, molarity is a conversion factor. So if we're given something, for example, as 1.50 molar, we can use that as a conversion factor because we know that we have 1.50 moles of that substance over 1 liter of solution. So let's look at two example problems. The first one says calculate the volume of 0.324 molar sulfuric acid needed to completely react with 2.792 grams of sodium carbonate. So we're given an equation. Always check to make sure that it is balanced before you start. In this case, it is balanced as written. Everything is in a 1-to-1 ratio. So we're going to be starting with our grams given in this case. Molarity is our conversion factor. So we start with 2.792 grams of sodium carbonate, Na2CO3. And as always, we are going to calculate the formula mass for sodium carbonate. Remember to use or round all of our atomic masses from the periodic table to 2 decimal places. When we do that, we should get a value of 105.99 grams per mole. So we want grams to cross out, so the 105.99 grams of sodium carbonate goes in the bottom, so our units cross off, and always paired with the formula mass is 1 mole. Now we want to go from moles of sodium carbonate to moles of H2SO4, but we want a volume of H2SO4. Well, it's the same thing as if this was a mass-to-mass problem. To go from moles of one thing to moles of another, we have to use our balanced chemical equation and the coefficients. Everything is in a 1-to-1 ratio. We want to get rid of moles of Na2CO3, so I'm going to put 1 mole of Na2CO3 on the bottom and 1 mole of H2SO4 on top. That allows me to cross off moles of Na2CO3. Well, we don't want our answer to be in moles of H2SO4, we want it to be in volume. Since we're given a molarity, that tells me how many moles I have per 1 liter of H2SO4. Well, liter is a measurement of volume, so that would be good. It doesn't specify what unit of volume. So I know that I can use that molarity because that's 0.324 moles of H2SO4 per 1 liter of solution. So I'm going to put the 0.324 moles of H2SO4 on the bottom and 1 liter of H2SO4 on the top. That allows me to cross off those units and go ahead and pause and calculate this. Report your answer to the correct number of significant figures. When you unpause, we'll go through the answer. So when you look at this, you divide these two, hit equals, and divide the 0.324. Since both of these numbers are in the bottom, we divide. This has 4 significant figures. This has 5. This has 3. So our answer should have 3 significant figures. Our unit that's left over is liters of H2SO4. So that's our unit and our label. And you should end up with 0.0813 liters. If this asks for milliliters, it will be 8.13 milliliters. If we look at example problem number 2, find the volume of 0.505 molar NaOH needed to completely react with 45.0 milliliters of 0.250 molar phosphoric acid. Well, our equation's already balanced for us. We have a 3 in front of the NaOH and a 3 in front of the water. That part of it is done. Now, let's see what we're going to start with. Well, we can either start with grams or we can start with a volume. Molarities are used as conversion factors. So we're given 45.0 milliliters. Hopefully something is not registering with you a little bit, because milliliters and molarity really don't go together. Milliliters has to be changed to liters. If we're going to use this as a conversion factor, we know that that's how many moles we have per 1 liter. So I'm going to change this from milliliters to liters when I start the problem. So we know that we can move the decimal point over 1, 2, 3 places, or divide that by 1,000. It's the same thing. And we get 0.0450 liters of H3PO4. Since I have liters, I want to get rid of liters. Well, the 0.250 molar tells us how many moles we have per 1 liter. So 1 liter of H3PO4 goes in the bottom, and 0.250 moles of that same substance goes on top. Our next step, after we cross out units, once we're in moles, we can go to moles of anything else by using our balanced chemical equation and the coefficients. Well, we want the volume of NaOH. We're given H3PO4. There's a 1 in front of H3PO4 and a 3 in front of NaOH. I want these units of moles of H3PO4 to cross out, so I'm going to put that in the bottom, and 3 moles of NaOH on top. Now that I have that, I want the volume of NaOH, so I can use the molarity of NaOH to go back to liters. So the 0.505 is how many moles of NaOH there are in 1 liter of that solution. So our moles cross off, we're left with liters. When you're going from volume to volume, you can see you don't even need to calculate a formula mass, because it has already been calculated for you in the molarity. So go ahead and pause this video, calculate this, make sure your answer is to the correct number of significant figures with proper units and label. So when you do the math, you should end up with 3 significant figures in your answer, so 0.0668 liters of NaOH. That is our final answer.